everybody. Welcome back from your spooky Halloween weekend. Hope you guys enjoyed it. Had some fun dressing up maybe, got your fill on candy. Whatever you did, I hope you had a decent weekend. At least a decent weekend at minimum. I hope it was good. Hope you guys had some fun, stayed safe. Now we're back into the weekly grind of learning and showing that we're learning. So that is what I'm here for today. This is for my Block 3-4 Algebra 2 class. I am here to go over the quest that you just took for unit number 2. Okay, I'm doing things a little bit different this time around. If you want to do a retake on the quest, if you're not satisfied with your score, you're going to watch this video, follow along with me for the questions that you got wrong, taking notes on some things to show me that you're trying to do better, that you want to do better, that you really want to improve your understanding, and show that by retaking. So that is what this video is for. I'm going to go through each of the 10 questions that you had to do my best to explain them, and help your understanding so that you can show me that you're better off this time around. Okay? Let's see. All right, we'll get right into it here. Question 1. Which was one of the biggest missed questions on the quest. If h of x equals 4x minus 2, which of the following is the solution to h of x equals 3? Okay, first things first, this does not tell us that x equals 3. So many people were taking x equals 3 and substituting that in to our function, but that is not what this shows. We need to find the x value that makes our function h of x equal 3. So what is the x value or the input when the output or y value is 3? Okay, evaluating functions like many of you tried to do here, that was part of our first unit, but we have moved on from that. We are more mathematical than just plugging in a number and finding the answer. Okay, we are given the function value here, so we need to find the x value. So I take 3 and I replace h of x with 3. Because I know my function, my whole function here has to equal 3. I need the x value that does that. So I have 3 equals 4x minus 2. We would add 2 to both sides. We get 5 equals 4x. And then we have a one-step equation where we know we need to divide both sides by that coefficient because 4 is being multiplied by x here. So that gives us x equals 5 over 4, which is choice 2. Okay, the most common answer here, if you were to take 3 and just plug that in for x, you would get 10. So choice 3 was the most common wrong answer for this one. Okay, again, you really have to pay attention to what you're given and what you're trying to find. Okay, talking about solutions normally means we're looking for x values. Okay. Number 2, for the function shown below, which of the following represents its domain? So domain, you want to think x values. X values are our domain. Okay, so we're looking left to right here, not up and down. Domain is just left to right, all our x values. So we want to find our lowest x value and our greatest x value, right? I always had us write out our minimum, our maximum. So our minimum x value here looks like it's at -6, and our maximum x value is at 8. So we're focused on -6 and 8. So that means either choice 3 or 4. Okay, choice 1 and 2 deal with the range values, -5 to 3 going up and down. But we're at -6 and 8. But now it just comes down to the different brackets. You'll notice in choice 3, the 6 has a curved, -6 has a curved bracket, 8 has a straight bracket. For choice 4, -6 has the straight bracket and 8 has the curved bracket. So what's the difference between those two? Hey, hopefully you guys remember that the straight bracket means that value is included. The curved bracket means it's not included. So look at the graph then. What do you notice is different? Well, on the left side, when x is -6, we have a totally filled in point. That means -6 is included there. Then if you look at the other end of this function, when x is 8, we have an open circle. That point is not filled in, which means that x value is not included. So -6 is included, 8 is not included. That means choice 4 is our answer. This means the domain is all the x values, starting at -6 and including -6, all the way through to 8, but not including 8. That x value is sadly not included. Not this time around. Okay? Moving on to number 3. A function f of x is 1, 2, 1, and it's defined by the set. Right here, there's our set. Which of the following could be the value of k? Which of these could be the value of k? Right there. All right, in order to answer this, you need to remember, what is a one-to-one function? What's it all about? A one-to-one function is a function that does not have repeated y values. There are no repeated outputs. Okay, graphically, a one-to-one function passes the horizontal line test. So we need a value of k that we don't see in any of these other y values. Okay, so can k be 5? Well, do we have a 5? Yes, we do. So k cannot be 5, because then it would not be 1-to-1 because of those repeated y values. -2. Oh, right there is a -2. So not -2. What about 3? Boom, boom. Oh, there's a 3. What about 0? Do we have a 0 in our y position? No, we don't. So k can be 0, and that would make this function 1-to-1. All right. Moving right along here, number 4. If f of x equals the negative square root of 6 plus x, and h of x equals 2x minus 3/4 x squared, which of the following is the value of h of f of 30? H of f of 30. So first of all, what are we working with here? We have two functions composed together. That's right, we have a composition of functions. So you start on the inside. F of 30 means I'm first working with this function here. So I'm substituting in 30 for x. So that equals negative square root 6 plus 30, which equals a negative square root of 36, which equals -6. Okay, so now this is our first output, which becomes the input then into h of x. So now we switch gears and we're focused on this function here, this fancy, somewhat messy looking function. So I now evaluate h of -6. Divided by 2, parentheses -6, minus 3/4, parentheses -6 squared. Okay, important here when you're evaluating, put those inputs in parentheses. Because this exponent here, that 2, that square, that only applies to this -6, and that should be done first. Before you multiply here, you need to apply that exponent. So 2 times -6, that first term is -12, minus 3/4 fourths times 36. All right, and then multiply 36 times 3 fourths, which is negative 27. So we have negative 12 minus 27. That comes out to choice 3, negative 39. All right. There we go. Number 5, moving right along here. Which of the following values of x does not lie in the domain of y equals negative 2 times the square root of 5 minus 2x? Okay, keyword there again is not. I stress to you guys that you need to read carefully so you know exactly what you're looking for. And we have a square root function here. And what's true about square root functions, as far as we know right now, right, in our mathematical career so far, we cannot have a negative value under the square root. So that 5 minus 2x has to be either greater than or equal to 0. It has to be greater than or equal to 0 for x values to be in the domain. Any x values that don't satisfy this inequality will make this function undefined, which means those x values are not in the domain. Okay? So let's see here. I'm going to subtract 5. I have negative 2x greater than or equal to negative 5. And then I divide by negative 2. Divide by negative 2. And guys, important here to remember, this is a little tricky concept. If we're solving, working with inequalities, and we divide by a negative or multiply it by a negative, that inequality symbol changes directions. So what was once greater than or equal to becomes less than or equal to. And now this tells me that all my x's that are less than or equal to 5 halves, or 5 over 2, will satisfy this inequality, which means they are in the domain, because they would make this function defined. So we need to find one of these values does not satisfy this. Is negative 3 less than or equal to 5 halves? Yes, it is, so negative 3 is in the domain. What about 2? Is 2 less than or equal to 5 halves? Well, 5 halves is 2.5. So yes, 2 is less than that. What about 2.5? Well, 2.5 is equal to 2.5, so that does work. Last one, 4. Is 4 less than or equal to 5 over 2? No, it's not. So 4 is not in the domain. If we plugged 4 in here, we would get a negative value under here, which makes this function undefined. So 4, not in the domain. Last multiple choice question right on the back, or on the next page, I guess, because this was all electronic. If f of x is a 1-to-1 function and f of 3 equals 8, then which of the following must be a true statement about its inverse function, f inverse of x? Okay, the fact that they tell us this is 1-to-1 is just so we know that its inverse is a function. Okay, because remember, a function will only have an inverse that is also a function if the original function is 1-to-1. So if we have f of 3 equals 8, that represents the point 3, 8. And that's on f of x. Okay? When we are now looking at the inverse, f inverse, remember you do the old switcheroo. You don't negate these. The point does not become negative 3, negative 8, but they switch positions to give us the point 8, 3. And 8, 3 corresponds to the notation in choice 1. F inverse of 8 equals 3 is what this point represents. Or that represents this point. Okay, our point on our original, becomes this point on our inverse function. Very important concept to remember. All right, on to number 11. Devin is selling small bags of cookies at a fundraiser for $1.25 each. If the amount of money he makes, M, selling B bags of cookies is modeled using a function, then determine whether $10 could be a member of this function's range. Okay, so we have to figure out, is M or B our range? Which one is our dependent variable? Well, think, does the amount of money he makes depend on the bags of cookies that he sells? Or does the bags of cookies that he sells depends on the amount of money he makes? Think about that for a second. Okay, it's the amount of money he makes M, that's our range. All the possible M values are our possible range values. So can $10 be a member of the range? Will he ever make $10? Well, that depends on how much he sells and what he's selling them for. Okay, so think, for one bag of cookies, when B equals 1, that means M is 125. When B equals 2, that means M is 250. When B equals 3, M is 375. Okay, so you'll notice as each input goes up, the output is a multiple of $1.25. It's going up by 125. So will this ever equal 10? And the answer is yes. By the time B equals 10, he sells 10 bags of cookies. When B equals 8, that will give an output of $10. So yes, 10 is a member of the range. All right. 13 is the function y equals absolute value of x minus 5. Is that a one-to-one function? And again, the key with one-to-one function is no repeated outputs or y values. Okay, because those are the same thing. So a one-to-one function cannot have repeated outputs or y values. So the key for this, you would have to, unless you know automatically what that looks like, which you might, you should enter that into your calculator. Okay, and that gives a graph like this. Absolute value, it has the shape of a V. And when you do that horizontal line test to see if there's repeated y values, to see if there are repeated outputs, you would see that yes, there are, because it fails the horizontal line test. Wherever you draw that line through, you will fail that test. So this is not one-to-one for this reason here. Okay. Number 14, f of x is shown graphed below. A very nice linear function here. Create the graph of its inverse. Okay, since I couldn't see your papers, and since you guys didn't have this on paper, I asked you to turn in or to tell me points that would be on the inverse. So to do that, you would want to write down at least a few ordered pairs on f of x. So let's see, we have -4, -10. Then we have -2, -7. And we have 0, -4. Okay, so those are 3 points on my original f of x function. And when we switch to the inverse, remember the inverse applies the old switcheroo, x becomes y, y becomes x. So these points become -10, -4, -7, -2, -4, 0. Okay, that would have been enough. I asked for at least 3 points, a minimum of 3 points. You could have given me more, but 3 points would be sufficient. Okay? Last one on the last page here, question 15. I asked you guys to do C through E. That's all based on this graph up here. This is f of x. How many solutions would exist for the equation f of x equals 1? So you must know here that that means the function value is 1 or y equals 1, which technically represents, you can draw a horizontal line through y equals 1. So if we're looking for solutions, again, we're looking for x values that solve this equation. And the x values that solve that equation are any points that hit that line that I drew in. Okay, so here we have 1, here we have 2, here we have 3. So there are 3 solutions. Okay, this is x equals -3, gives a function value or an output of 1. Here it looks like x equals 5, gives an output or function value of 1. Down here, it looks like maybe 8.5 when x is 8.5. Again, that gives a function value of 1. So there are 3 points where the function is equal to 1. And you had to explain something about if you drew that line across, or you knew to look for anywhere on that function where the y value was 1, some kind of explanation to show me that. All right, letter D. If g of x equals this crazy function, then determine the value of g of f of -3. So again, we have a composition of functions here. F of -3 is what I want to start with. So I first look to our graph. And f of -3, that's actually one of the points we already circled. So f of -3 equals 1. Now that output becomes my input into this function here. So g of 1 equals -8 times 1 minus 4 times 1 squared. Let's move this over. That's all divided by 6. That equals that, just cleaning it up here, -8 minus 4 over 6 equals -2. And that now being our final output is the value of g of f of -3, the value of this composition. Alrighty. And the last one I'm just going to explain here, so listen carefully. It says explain why the function f of x, why this function will not have an inverse that is also a function. Okay, and that goes back to that one concept about a function will only have an inverse that's a function if this function is 1-to-1. So only if a function is 1-to-1 will it have an inverse that is also a function. So you have to check, make sure or not. Actually, it says explain why it will not have an inverse that's a function. So why not? Well, f of x is not 1-to-1. F of x is not 1-to-1 because it fails the horizontal line test. That means there are many places where outputs are repeated. There are many x values for which the outputs are repeated. For that reason, this function is not 1-to-1, which tells me that my inverse function that my inverse will not be a function because f of x is not 1-to-1. So I needed something about the original function not being 1-to-1 or failing the horizontal line test to tell you that the inverse would not be a function. It was not enough just to say the inverse will fail the vertical line test. Yes, that is true, but how do you know based on what we have? So that is what I needed to hear in your explanation. Okay? So those of you that took the time to do this, way to go. Kudos to you for wanting to do better, for wanting to improve, for wanting to learn, way to take that initiative and take advantage of your opportunities. That is much appreciated and will go far. So thank you.